The overview of our project can be translated in a conceptual framework. It has 5 inputs and 3 outputs. The first input is the procedures, which will have its experimentation. The second is the retrofitting, which has the electronic fuel injection, the primary coil, and some experimentations. The third input is the experimentation for fuels and additives. The fourth experimentation is for oils and lubrications. And the last input is for the instrumentation and controls, reconfiguration, and adding. With these 5 inputs, the engine testbed can produce 3 outputs. First is for the experimentation for academic programs, which will analyze power, emissions, and fuel economy. The second is for students to be trained for repairing and tuning of gasoline engines. Lastly, this is required for fuel testing, whether it is efficient, less emissions, or other advantageous aspects. So our conceptual design consists of the following components. We start off with the air receiver, which will indicate the amount of air required for the pressurized tanks. This will be displayed from the pressure gauge and will be regulated by the pressure regulator. The pressurized air contained inside the pressurized tanks will now flow in the fuel injector. The fuel injector is controlled along with the instrumentation of the fuel pump to mix the air and fuel ratio. With the right amount of air and fuel mixture, it will now flow in the gasoline engine, which will be measured with the tachometer for its RPM. The gasoline engine will have 2 outputs. First is the exhaust, which will also be required for the analysis of its emissions. This will require the exhaust gas analyzer. Another output will be for the generator. This will first be attached to a flexible coupling, then to a torque sensor, another flexible coupling, and then the generator. The generator will produce 2 measured values. First is the current, which will be displayed in the ammeter, and the second one is the volt, which will be measured in the voltmeter. Lastly, the gasoline engine will be attached to a thermocouple to maintain its operating temperature. If successful, our project will be able to display the velocity bar graph for the velocity value, the fuel consumption value, and the timer display. It can also measure the number in which fuel is injected for the amount of injected fuel, the fuel consumption value, and the total running distance. It can also produce an output for the engine RPM, the engine hour meter, the power supply voltage, and temperature.